I just want to introduce everyone together. This is Harley Smith. This Gardy and Matt are part of Drops of Balance. They've been also working with minerals for close to 20 years. And then Macaulay is the soil biologist and the third-party company we ran the tests with, that you'd be able to ask any questions and just kind of become more familiar with any of the methodology he used while growing.
Yeah, just to clarify, I'm not a soil biologist, I'm a molecular biologist and biochemist.
Sorry.
Oh, okay. I do suspect after reading the report that there may be an element of the microbes in the soil that are part of what's having a positive effect on the plants.
Definitely.
Mm-hmm.
So I'd like go ahead and start off, Harley. What do you think? What was your overall interpretation of the report, and what's going on?
Yeah, like I just said, the thing I'm suspecting is that having the most significant results are the ones with the soil pretreatment, right?
Mm-hmm.
And I was wondering, a lot of times there's a limiting factor. Maybe there was one trace element that was limiting, or maybe there was competition in the soil for an element. But I didn't rule it out completely. But the plants that were foliar sprayed that contained the product didn't have the same response as the ones with the soil pretreatment.
It wasn't just foliar spray, they were watered with it in soil as well.
No, yeah, they were watered with it, but it wasn't pre-treated though.
Correct, yes.
Okay, so that's the point. So my thought is that overall, that there may be an effect of the heavy metals on the microbe metabolism in the root zone of the microbes. It's just a kind of like you said, my overall, because I did see that in some of the early experiments, and I was working with some scientists from Germany that were working with contaminated soils years ago, and they were able to come up with some of the very first organic biostimulants to unlock the minerals in the soil. And they literally said that one of the experiments they did was with the microbes. They saw where there was heavy metals and contamination, the microbes were very sluggish under the microscope. They were just barely moving around, didn't have much energy. But then when they added the biostimulant product, immediately the metabolism of the microorganism significantly increased, even though they were still subjected to the heavy metals. And as they started vibrating with energy, they started to divide. As they said, it was like watching a cartoon under the microscope. You had to divide, pop, 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 much more quickly. And it's when the microorganisms are actively dividing that they provide many of biological compounds that plant growth promoting rhizome microorganisms produce. They make rooting stimulants. They activate the immune system of the plant. The systemic induced response, the systemic acquired resistance of the plant against a host of microbes. They aid with the uptake of nutrients and to stimulate the metabolism of the plant itself, because they're making chelators, siderophores, and other compounds. So I kind of was thinking, since the pre-treated soil seemed to have the most impact, that perhaps there had a remediating effect on the microorganisms in the soil caused by pre-treatment. And that's something I'd be interested in learning more from you guys about, how you did that process of the pre-treating and the flushing. But that's kind of my conclusion at this point. I've only looked at this for about an hour and a half or so, a couple hours. So I wasn't able to dive really deeply, but I think that may be, if not the key, that may be a very significant component of why the Drops of Balance were so effective in pre-treated soil.
Yeah, that's definitely a possibility. The lab that we use is a standard 17025 lab that just tests for contaminants. So a full spectrum microbial analysis wasn't possible. But I definitely agree with you, just given what I've learned about this product, Drops of Balance, and Matt could probably speak more to it since he's been dealing with it longer, is that it could have definitely had a positive impact on the microbes, because as far as the remediation of the heavy metals themselves, that was inconclusive in the report, because the control and the treatment groups basically all showed below LOQ in the analysis. So it's definitely a possibility that the Drops Balance had a positive effect on the microbes that were able to overcome the negative impact of the heavy metals that we knew were in the soil because I did a homogenization test of the soil prior.
Yep. That's kind of an area. If I was going to focus for follow-up, that would be the area I'd focus on the most. Maybe not trying to map every microorganism in the soil, because if that remediation that's happening, however that's happening, will work on a multitude of microorganisms. So it's not like we got to find out every single microorganism that's there.
So to get my head around what both of you guys said, just to make sure I heard this correctly, was even though there was a below LOQs of heavy metals in the initial starting soil, even though it was still below that, those heavy metals that were there and potentially could still have that much of a detriment to the soil biology, even if it's below LOQ. And I'm guessing that the soil that wasn't pre-treated with a higher concentration probably just wasn't, there wasn't enough minerals to lock up the heavy metals potentially, or hold them back, versus pre-treating them early on, you kind of lock them up in the soil or don't even allow it to interfere with the soil biology at all. So it allows the soil to get healthier earlier. And that's why we're seeing the better results, you're thinking?
Well, though the soil had heavy metals in it, because I did the test to ensure homogenization of the soil before everything was potted in the pre-treatment and treatment groups and all that good stuff. It was the uptake of the heavy metals into the plant is what was inconclusive. And that was one of the things that we were testing for, was does drops of balance have the capacity to remediate out the heavy metals in the soil, which we showed that it didn't. And then we had the hypothesis that maybe that it's creating a precipitate where the plant can't uptake, but because the control and treatment groups didn't show anything in the plant material as far as heavy metals are concerned, that's what the part that was inconclusive. And what I think Harley is saying, and correct me if I'm wrong, Harley, is that just even though, because we know the heavy metals were there, because we had that initial analysis of homogenization, the fact that the drops of balance was in the pre-treated soil prior to it potting, it allowed the microbes to overcome the detrimental effect of the heavy metals that we knew were there, which would allow the plant to have a better metabolism and a better efficacy of removing the pesticides that were being sprayed on it or watered with it.
That's very good summary. That's exactly what I'm saying. Remember too that some of those microorganisms, the plant growth promoting microorganisms, are literally helping to sequester heavy metals. That's one of the things they do, and they aid with the uptake of nutrients. And the other one too that I think is kind of interesting too, some of those microorganisms, just like regular garden soils and nothing special, Bacillus subtilis, GBO3, it makes volatile organic compounds that can initiate or turn on up to 600 genes in the plant, even if it doesn't touch the roots. The volatile compounds themselves can have an effect on the genetics of the plant. So if there's more activity, that they're going to provide more plant protection, and they're going to activate the metabolism of the plant.
So you think some epigenesis might be going on?
Yeah, there's something going on that, well, again, that's where I think it is, because I don't have another explanation, because it's not directly from the trace elements that you're adding, because you're doing that when you're watering in at a lower dose, and you're doing it when you're adding your foliar sprays that's treated in the water. So it wasn't like there's something missing that the drops of balance gave. I think there was an initial response early on in the pre-treatment process itself.
Yeah, and I mean, I think that data bears that out, because with the treatment that didn't have the pre-treated soil but got the drip system and foliar spray was statistically insignificant difference from the control group. So there's another factor at play, and I definitely think microbials would definitely be a huge contributing factor, and that would explain the difference between the two treatment groups.
Yeah, that's just like kind of a bottom line thing to look at some more. Also, the size of the sample that was the pre-treated soil, there were only 16 plants.
Yes.
Yeah, so that's not a really great indicator. There's not enough there. If you were able to do a follow-up with an treatment of any kind to kind of look at what's going on in the root zone, just have ones that's pre-treated soil and the other was not pre-treated soil and see the difference.
Yeah, that's definitely the next step that we would try. There is a reason why we had a smaller sample size. Initially, we weren't going to use the whole greenhouse for the farmer. We were just going to have, 2 equal sample sizes, or 3 equal sample sizes rather, and test those. But once he saw kind of how the clones were reacting with the pre-treated soil, he was like, I just want to use this on my whole grow. And then, so that gave us that group without the pre-treated soil. And then we just did the control group. So it was like I want to say like a fifth of the greenhouse was the pre-treated soil, and then 2/5 was the other treatment. And then the other 2/5 was the control group. So that's kind of how that came to be. But if we were going to be doing this experiment all over again, definitely we would split it up into 2 equal pre-treatment and treatment, since we know as far as metabolism for terpenes and cannabinoids go, that there wasn't a difference between the control and the non-pre-treated soil. So it would only make sense just to do the pre-treated soil. But in a way, it is good that we did it this way, because now we know that without pre-treating the soil, we're not getting the benefit of that metabolism. But we did see the reduction in pesticides between the being relatively the same from the pre-treated soil to the non-pre-treated soil, which is a different discussion altogether. But as far as the metabolism is concerned, I would 100% agree with you. For future tests, we would just go with control and treated soil.
Did you take any leaf tissue analysis to see what elements were accumulating over time and which were becoming deficient over time?
Unfortunately, no, the lab didn't. I did ask the lab if they had that capacity, and they did not.
Okay.
And there is other labs in the state that did, but when I found them, we had already started the experiment and sent a number of tests to this lab, and I did not want to switch labs partway through the experiment, because that would be a big issue for consistency.
Oh yeah. Yeah. I mean, there's already a lot of variables without changing the lab too.
Yeah,
for sure. Though the leaf and tissue analysis is something I used a lot in my research to find out what might be the limiting factor. And then they have to do the kind of the detective work to ask why. I'll give you an example. A good example, I think, is when I told Mark earlier in a previous conversation, I helped a grower in the state of Oregon win first place in a contest for the whole state of Oregon. He was first in terpenes for the state, first in cannabis and THC. So he won 2 first prizes, and they all the growers were top growers, but they were all given the same genetics. So there was no from the same mother plants. So it really wasn't what's the genetic potential. Now, what I did to help them is I did some leaf analysis, because there was one stage of growth where the plants were underperforming. That was kind of in the transition period, that early flowering. And then they would get some symptoms of some deficiencies, but they would eventually come out of it, but not reach their genetic potential. So I just did side by side. I took some leaf that were showing some symptoms, took another leaf that were showing no symptoms, it was my lab, by the way. I had my own ICP OES spectrometer there right next to my office. That was kind of nice. But we ran them side by side, and the one that showed the symptoms had 1/3 of a trace element, manganese. And we're talking about trace elements here. They had 1/3 the manganese as the one that showed symptoms. So we said, well, it wasn't, even then, it wasn't considered deficient, but it was much lower. So I tried to figure out why. So first thing we did is we increased the amount of blue spectrum so the stomata would open, so we get more transpiration of better uptake. We ramped up CO2 instead of going up all at once, because increased CO2 until it adapts, closes the stomata. The blue stimulates the stomata to open, so there's not as much transpiration. And of course, we had to treat the symptom. So we made up an amino acid chelate, manganese amino acid chelate. They used it as a foliar, and they added it in the next round. They added it to, the end of veg 2 in the nutrient. Anyway, the bottom end of the story was they went from the worst room, underperforming room, to the best room ever. But right after that, when they were implementing these changes, they were doing the trial. And it turns out that manganese is a very important coenzyme to turn on metabolism for terpenes production in the plant. And as the terpene level went up, so did the cannabinoid level go up. So once we found that limiting factor and treated that, manganese was no longer the limiting factor. Terpenes went up higher than any grower in the state, and the THC followed it. And I have it right. I have a metabolic pathway chart on my wall. I've always been interested in those coenzymes for metabolism of the cannabinoids, especially the sesquiterpenes, which really turned out what were highest in your particular strains. So, taking a look at the leaf analysis along the way too can give you some very important clues as to what's going on inside the plant to make that significant difference with terpenes and THC.
So you're
giving up, but you're doing it. See, I halfway ruled it out, a limiting factor, because you're also watering it in with all of them, in the experiment, plus foliar spraying it along with all of your additives for foliars. So I'm saying, well, how could it be one trace element? So that's why, again, I think it's more than that, but there still may be a limiting factor going on with with the unremediated soil, affecting the uptake of something like manganese or iron or copper.
I think, tell me if I'm wrong, Macaulay, he was using some type of a H2O product to kill the microbes, wasn't he?
Yeah, he was using peroxide.
So I'm just throwing this out there. Would using peroxide, if using peroxide hindered the bacterial growth on the plant, or maybe even in the soil as it drips down? So because we're talking about the play right now with soil biology, right? Being able to overtake it. And I know no matter what, you can't get rid of biology in a plant, no matter how much O2 you put, sterilize the environment. I tell me if I'm correct on that. But let's say we're trying to hinder it with the H2O2. What could be the other play on that if the H2O2, the hydrogen peroxide was knocking back the bacteria every time they were spraying or putting it into the plant? Were they putting it into the root system too, or just foliar spray?
No, God, no. No, it's just foliar spray.
Okay.
And that was only applied a couple of times for mold purposes.
Okay, so it wasn't all the time.
Okay. Yeah, the hydrogen peroxide in general, if it's at high levels, it's going to have an effect on the root hairs too. It's going to oxidize the microscopic root hairs. Not a good thing. It's going to burn them, stunt the plant. But remember, hydrogen peroxide, if there's just a little bit of residue from that, it breaks down into oxygen and water. And that will give a competitive advantage to the aerobic microorganisms, which are most of the good guys. The bad guys, the root rots, are the anaerobic. They grow in stagnant water without oxygen. Even a little oxygen will kill the root rots. I guess I could tell you one little experiment that I did with hydrogen peroxide a while back is I was looking at the sweet products, the sugars, different sugar products that are out there in the market.
Yeah.
Now, remember, microbes need a carbon source and they need a nitrogen source. So we set up a whole experiment, lots of different environmental control chambers, and we were testing the different sweets products side by side. I would mix up a full-strength nutrient, take a sample, including whatever they said the dose is for the sugar, send it to the lab. 3 days later, it was coming back 0 nitrate nitrogen, 0. And I'd put up, that was without any plants or anything. I just had added it to the reservoir, stirred it up, took a sample. And it turns out what was happening is in my hydroponics, about 90% of the nitrogen came from nitrate and no more than 10% from ammonium. So what I was doing in this thing, giving the sugar was giving a competitive advantage to the microbes that were denitrifiers, that would use nitrates as their nitrogen source. And normally, those are anaerobic microbes. So, I found out, did all the research, I figured out they were changing the nitrates into nitrites, and the nitrites were toxic to the plant, and so forth. But to remediate, I started adding hydrogen peroxide, and it had less of a negative effect. So the hydrogen peroxide was adding a little extra oxygen to the microbes that are typically anaerobic. I'm just giving you an example. So the hydrogen peroxide in small amounts probably would have a positive effect on the plants, and not because of a contamination, just positive effect on aerobic microorganisms.
That allows us to keep going down the direction, like you said, with the relationship between bacteria, clean water, and minerals, and the coenzyme reaction play. So before we go into these other parts of the report, was there anything else that popped out at you with this area around heavy metals and soil biology and its relationship?
Yeah, I was a little curious, the fact that there were several crops before in that same soil that failed heavy metal analysis, and that for some reason only one sample that in the control, like the second sample you took, only one of them failed heavy metals, and that was for arsenic. So the question to me was, if this was known contaminated soil, then why didn't any of the plants, including the control, show negative effects when all the plants grown in it before had shown negative effects and failed?
Well,
was it flushing? Was it because that they were all pre-treated with water? Maybe got rid of some heavy metals? I don't know. I don't have an explanation for that. Do you? Thoughts on that?
The only thing I could think of it was the pre-treatment with water, because I put it in a giant pile, homogenized it, and I tested it, and all those heavy metals were still in there. So it was like, okay, they're in there. And yeah, because I was kind of flabbergasted by that. I mean, it's either the water flush with the rinsing over that 72-hour period did it, or two, the lab botched their ICP-MS analysis, which I think the former is the more likely.
Yeah. So
could the density of the heavy metals just run through the soil when you did a soil wash with the well water versus the mineral water when you pre-treated that? Is that a possibility?
I doubt it, because he flushes the soil when he pots before, like he always does that. Granted, it never got this much water, because this was, every like 4 to 8 hours with a few gallons of water over 72 hours. So there was a lot more flushing going on. That's really the only other explanation I could think of, like Harley already pointed out.
Yeah, I'm wondering, did you do a test for heavy metals after the flush and before planting?
We did not.
That could tell you if we had already lowered the amount, if any, significantly in the soil itself. But even though that may have happened across it all, everything for flushing, but the ones that had the drops of balance had a more of a positive effect, even, because the flush alone wasn't what was doing it. The heavy balance had that. Drops of balance.
And with our water experiments we've done over the last 20 years, when we do and Matt, confirm this with me for me, please, from chemical, VOC, heavy metals, they precipitate out the water, and when they precipitate out the water, they get locked up, so they're no longer water soluble. And then, for drinking water, we run it through a 0.2 micron filter just to make the water look nice. But at that point, the heavy metals are no longer part of the water, and they're inert because the molecular structure of them, the chemistry of those heavy metals have also been altered in some level, one way or another. So they're no longer harmful. So, for example, the chromium. We have experiments with, I believe it, Matt, help me out with this. Is it chromium 3 to chromium 6?
No, it's from chromium 6 to chromium 3. So what essentially we have is an ion exchange process that takes place between water and the mineral salts. And so if you have contamination in the water, you will have exchanges, electrons will, like, chromium 6 to chromium 3 is just a matter of 3 electrons.
Mm-hmm.
But you'll also have other exchanges, like for instance, if you have sodium fluoride in water, it's dissolved as one sodium and one fluoride ion. And in nature, you would have calcium fluoride. So what happens is you end up having 2 fluorides per calcium. And so the minerals need calcium fluoride to become, I guess you could say, inert or natural. The way I look at it is if the host, whether it be human, plant, animal, receives the bioavailable harmful kind that needs to be completed, we have to donate whatever it is to complete it, to make it what it needs to be to bioassimilate it. And so if we're donating to, say, fluoride in water, we're giving up our calcium ions to make that fluoride not be toxic to us or be free radical. And in this case, an ion exchange is taking place ahead of time, where now those are no longer in those states or in those, like we were talking about, precipitate versus the dissolved substance, or just the fact that they're in one state rather than another in the presence of the soil or in the water is enough to make things not work properly, especially in soils. And what you're seeing is, yeah, go ahead.
I'm sorry, guys. I gotta jump off.
All right, Macaulay, it was nice to talk to you. Okay, so I guess I'll finish saying what I was saying. Yeah, when it comes to the ion exchange process, we don't know the mechanism that creates it's the complex. So I don't know if you know much about this product, Harley, or I think I've been working out with it for 20 years. I work directly with the Japanese manufacturer, and I also basically help get it to the American markets and the world markets for them. But they did research back in the 70s, 80s. The actual founder / inventor / discoverer, his job was to clean radioactive waste. So he was a biometallic chemist, and he had a vision for how God or how nature or how this creation purified water. And so he went around the world looking for the perfect mica. And in terms of their research and what they found in extracting mica in sulfate form, in its complex form, high in iron, it has to be high in iron. There's magma. So you have 2 volcanic eruptions. You have your felsic eruptions, which is your white ash cloud dust mica, which is very mineralless. It's mostly just silica and alumina, which is where you get your alumina silicates. And you have your mafic, which is your magnesium and ferric iron magma. And so those are the ones that are the lava and the magma that come out of the volcano, not explosive into the air. And that's where you get your biotite mica and your iron-rich mica. Now, I've done a lot of research and I've been working with this, and I've had to come up with all kinds of different of my own understandings of how it works and what the anomaly is. But one of the things I'd like to point out to you, and a few things, because I don't have much time with you, and I'd rather take advantage of that while I have time with you, is the ability to create cellular life starts with ferric iron and sulfur, and it's called the biogenesis of a cell. And we can see that take place under a microscope, especially with this product. And there's actually a natural health product license to create healthy cells and maintain healthy cells, and also can be used for anemia with this product. That's actually registered already. It's been around for a while, but there's not a lot of people in Canada. But you can see the healthy cells form with the ferric iron and sulfur present. But then also on the agricultural side, and I believe the more important side in terms of where this can go, is the product has the ability to help the plant convert more nitrogen and can help get rid of nitrogen toxicity. And when it does that, and this is my hypothesis / whatever you want to call it, is that what we're seeing take place is these primordial metabolites, like what is it called, isoprene, have a higher rate of conversion. And that can only happen when the microbials and all the other things are lined up. But the ability to convert more nitrogen would explain the ability to create more of these, because that's in the stages where the conversions take place. You need nitrogen. That's how the sugars get formed with the carbon dioxide. And that's the mechanism that I'm interested in. That's the mechanism for humans and plants that create these metabolites that control our immune systems, pretty much everything, all of our functions. And each one can be linked, I guess, to a mineral or a group of minerals, which is obviously the reason why the complex, I believe, is so effective, because you get the complex. And lastly, I'd like to address one other thing just to put into your mind in the analysis of all this is I've worked with some water people in the past, and I once was working with we didn't work on anything together, but we've had some time on the phone. And one of the guys that's the leading guys, doctors, and Dr. Gerald Pollack out of Washington State, he wrote some books on fourth phase water, the four phases of water, liquid plasma being the fourth phase. I'm just going to skip right to it, where exclusion zones can be revealed, and testing that shows UV absorption is the way to prove that. And that is one thing our product does do. It does create the liquid plasma state. And so I know that has a lot to do with good things in, bad things out. I guess that's the most basic layman's way of saying it: good things in, bad things out. And that's pretty much it. That's my overall understanding and view and reasons, I guess you could say, as someone who's been working with this product and helping people get this product over the last 20 years. That's my 2 cents on it. So I would like to hear your take on some of those topics and see if that triggers anything that you have to say about that.
Yeah, it does trigger some stuff. But the first thing it always triggers is the question. In the drops of balance, it's sulfonated trace beneficial elements or essential elements. Is that something like iron sulfate and manganese sulfate, zinc sulfate? Is that what we're talking about, those salts?
Correct. Everything's in ionic sulfate form, yes.
Okay. Which typically, to me, is less stable, because as far as uptake of iron, it's not taken up by in the ferric state, it's taken up in the ferrous state, and plants literally make enzymes exude enzymes from their roots that will change the ferric iron into ferrous iron. And then, of course, there are different oxidation states inside the plant, like in the electron transport chain for photosynthesis. All good things. But so my question is there other ingredients in there besides water and trace elements?
No, it's actually the extract out of biotype mica, as is. So what I found, I've been working with geologists and people who are into other fields about minerals and all of that. And so when it comes to magma, right, the higher the iron. Now, if you look at the surface of the earth, you have oxygen, silica, aluminum, iron, right? Those are your top 4 in order. Mica is very similar because it's obviously the surface of the earth, black mica, biotype mica. But there is one element that can surpass aluminum when it comes to magma, and that's iron. As a whole, as an average, aluminum beats out iron. Aluminum's the top surface metal we have.
Mm-hmm.
But when it comes to the iron, once the iron levels go up, so do the other trace minerals. As the iron goes down, so do the other trace elements. So when you have a darker, more rich iron, and it's typically called black mica, which there is what's called supermafic. Supermafic would be extremely rich in minerals, and I think those could be in Montana, maybe somewhere from Yellowstone. There could be supermafic eruptions. But in terms of the content, it's the iron, and I think it's due to its magnetism, due to its role that it plays in fulvic acid. In fact, I believe fulvic and humic are part of the process of the earth delivering the form of iron that you would get from this formation into the ocean volcanic vents, all the way into your sulfur-based freshwater systems. That's where I come in. I'm dealing with a world that was full of sulfur minerals everywhere to a world that now, present day, there's nowhere to be found. They're a dying breed in our American land and in our history. A lot of places became famous, like Detroit, Mount Clemens. You're from Michigan. I'm actually in Michigan, by the way. I didn't know if you knew. Yeah, in northern Michigan. Yeah, I'm in northern Michigan, up near Gaylord.
Oh, I'm from Leelanau County, originally from Suns Bay, Northport area, up by Traverse City.
Yeah. So that's the main thing. It comes from a formation that what Shimonishi found was like kind of like what I did was I took an analysis of all the different sulfate healing springs that were left in the world. And this was back probably 10 years ago, but they all had a very similar ratio of minerals that you would find in the drops of balance. And that was the one thing they had in common. They were all sulfate. Now you get your carbonates. This was something that I discovered by accident, that if you take lab grade deionized water and you put drops of balance in there, you'll actually suck carbon from the atmosphere, create carbonates, and it'll become acidic.
Interesting.
Carbonic acid will form.
I think, let me ask a question here. That was one of in my notes, the pH of the soil in your test. I know if you get lower pH, you tend to get more uptake of the transition metals. Well, you know what the pH of the soil was in your trials?
I'll have to get back to you on that, and I'll text over Macaulay. Hopefully I'll get that before we get off the call.
Okay. Yeah, because I know that if you get low pH, from just listening to Matt here, if you get low pH, you tend to get a toxicity of some of the transition metals, especially manganese, will tend to actually harm the plant. It'll fight with the iron. Exactly what you're talking about here. But that was one of my questions, so I'm glad you brought that up with pH, because we're slightly, the carbonation, carbonic acid is slightly acidic, comes to wash away some of the carbonates into, you start getting bicarbonates, calcium carbonate, magnesium carbonate, then that's in your well water, and your pH tends to go up. So the carbon dioxide lowers the pH, but the bicarbonates buffer the pH up high.
Well, and then when they did testing on like slaughterhouse water, because the minerals have a flocculation effect. It creates deposition, flocculation, and coagulation, and then you have a fallout that's separated that will never mix back in, right? Because it goes this ion exchange process. And essentially, once that process is completed, it's done, and there's no unrendering it. There's no going back. But in terms of all these other inputs, like factors, there's a lot of environmental factors. What I would like to point out that we didn't really discuss was that the ones that were sprayed and given into the drip, even though they didn't have the high amount of THC and terpenes, they also had a very low amount of pesticides compared to the control group. So because you were in the environment that the pesticides were being sprayed, you could see the direct effects that the minerals had on that pesticide, whereas the control group didn't get those sprays, didn't get the foliar spray. Therefore, it didn't have the environmental exchange that allowed the bad stuff not to build up, which would be, the microbutanol.
Do you think that's because of the microbes on the surface of the leaves?
Probably, yeah. I would say definitely. I would say that in order to make the product work properly, you need to have both areas functioning healthy, and whether you need to do a pre-treatment with soil, the minerals, and then spray, you're going to have this dual effect of an environmental exchange that allows for the good microbials to thrive and the bad microbials not. Increasing the metabolic process would allow for a healthier plant, a more productive plant, because the metabolites are the beginning of all the things we're talking about. Like when you get that to the basic bottom of the whole entire, whether it's health of human, health of plant, or potential of health, or potential of immune systems, or, like plants, high Brix counts, you have to have a increased metabolic process. You cannot have a weak metabolic process and achieve that. So whether it's from the top or below, what you're really seeing in this test is that, hey, because we used it, so both samples got the outside spray. Well, what if you had just pre-treated the soil but didn't do the spray? Would we see microbutanol in that plant? And that's something where I think that there's a benefit to having both, and it could lead to saying, hey, to optimize your environmental cofactors of like how you absorb nitrogen, how you convert your metabolic process. You need to cover both areas to get the best results.
Just to combine what both of you guys have said as a hypothesis is because the biology goes basically dormant, you know, with heavy metals and just toxic environments, technically we don't know how fast the bacteria can actually break down pesticides and fungicides that normally have a longer half-life when the bacteria themselves are dormant. And so if we get them going again, that does kind of make sense that the bacteria now can do their job better, right? Is that what you guys are both saying?
Yeah, I'm saying that there are actually some strains of microorganisms that are very, very good. They can feed on lots of different substrates and are very good at breaking down residual pesticides and fungicides in the soil because they have such a wide range of carbon sources they can feed on. So there's some of the plant growth promoting ones.
This rolls into also the reduction in bud rot in the. Did you read that part in the experiment where both treatment groups only 10% of the crop went to mold, but the controlled group over 2/3 of the crop went to mold?
Yeah, I read that, and I thought that was really, really interesting. And it's kind of interesting too, though, that they had less mold. So it makes me wonder if those particular plants had their immune system stimulated earlier on or at some point, so they were able to fight off the mold. But it's a little, that adds more. I don't have answers to that because then again, the why is it that the ones that are sprayed have the same effect? You were saying that both both treatment groups, the ones with the pre-treated soil and not pre-treated soil, all of those had less mold.
Yeah, 90% reduction in mold. Only 10% of the crop went to mold.
Right.
And have you ever heard the thought process that the soil is what activates the enzyme that makes the powdery mildew or the bud rot open their spore?
It has to do with relative humidity. If you get a reduction, if you have powdery mildew and you reduce the relative humidity, it causes the powdery mildew to sporulate, to make more spores and spread.
So it's
really the change. I think it's really more at the, but it could have an effect because of the uptake of water and the transpiration of water. We could have a whole discussion on that because I did some tests from what I learned from the Netherlands. Who are using those same biostimulants, that they were able to improve the uptake of calcium, and the more calcium the plants took up, they were able to reduce losses to powdery mildew to zero, even with relatively high humidity. The calcium and the silicon working together, especially calcium, though.
This might sound stupid, but have you ever done an experiment seeing how fast water, when it becomes stagnated, how fast it becomes toxic? And could the relative humidity and the reduction of it or increase of it make water stagnated to the point where the spores open up, or where these things start to happen because of a stagnation of water?
They have stagnation of water, and it becomes anaerobic. It uses up all the oxygen, and then there's not oxygen to use for metabolism of the root cells that they need to take up water and nutrients, and also not metabolism for the beneficial microbes.
How fast does that happen? Have you ever done any experimenting on that?
I don't know, but I'm going to guess that's going to be relatively quickly, within a matter of hours. It's going to start. You see that I've had it. Well, I mean, I've had it happen. I had a deep water culture garden one time just for a mother plant that I had that was an award winner. So I had that in its own 5-gallon bucket system with water, and I had dual air stones in there to keep it oxygenated. The roots were healthy. Everything was great. And then the air pump died. So it was sitting in stagnant water. And within 3 days, it took before I recognized, oh, wait a minute, something's wrong here. And I lifted it up, and those roots were slimy, black. It looked like the plant was going to die. I went, oh man, I'm going to lose this plant. Now, darn. I said, well, I'm going to cure it or kill it. So I did a relatively high dose of hydrogen peroxide, dipped it for 30 seconds, lifted it up. The roots were snowy white, but I stunted the growth. I burned the microscopic root hairs. So it stopped growing for about 2 weeks, and then new roots took the place, and plant recovered. But yeah, so that stagnant water, I saw, definite major negative effects within 3 days. So when did it start? It probably started within hours or even that first day before it got worse and worse. But I'm not answering that definitively, but just from my experience.
What did you think also about the higher terpenes because the theory is that the terpenes volatilize off. That's what's been the predominant theory. But now seeing the experiment, I'm thinking the plants are actually cannibalizing them quickly, a lot quicker than we actually recognize or realize. And we think they're volatilizing off in the 3 weeks they're curing. But what's actually, I think, happening is when you start with the low terpene count, they volatilize off quickly. And so that's what ends up possibly creating the hay smell, because there's no terpenes left, because they're not, because I always wondered, when you look at the boiling points of all the terpenes, they're most of the time they're higher than the THC. So why wouldn't they stick around when they can't? When I know they're lighter, but that never made sense to me, because they have a higher boiling point. So wouldn't they stick around longer?
Yeah, well, partly true. I mean, you can see it. The sesquiterpenes, which are larger terpene molecules, they take longer to volatilize, and they have a higher temperature. So you see more. And it's kind of interesting when the plants are subject to stress. I saw this one. I learned the most when things go wrong.
Yeah, don't we all?
That's where I really learned the most. If everything's going great, I just say, oh, okay, I don't have to really look at this much. Anyway, there was one time, commercial grower, he was cleaning up a filter, turned off the water, and of course, he forgot to turn it back on, right, for irrigating. So those plants over the weekend received no water, and high intensity light and temperatures. So we lost, let me see, I think about 40% of that bench. It just died out. But the 60% that recovered, it was really strange. They literally doubled the caryophyllene amounts, the sesquiterpenes, over the ones that were before, that didn't go through a drought stress for a few days. Kind of interesting. So it's part of their response to make more of those agents.
We were talking about this on our last call before we did this, because there's a different set of terpenes on the plants that were given the minerals than the ones that weren't. So it made me wonder, when the plants are stressed out, could they possibly be producing a different set of terpenes through a defense mechanism within the plant, and not the health of the plant, right? So because we always talk about, like, some times when you smoke something and they get really anxiety. And so I was wondering, is it possibly because the plant was going through some type of a state that it produced a different chain of terpenes through a reflection of the health of the plant? And I know that's kind of hippie-ish, but now looking at this thing, I was just wondering, what type of terpenes get produced when there's aphids? What type of terpenes get produced when there's spider mites? What type of terpenes? You know what I'm saying? And yeah, I was just wondering, did any of that trigger anything for you guys? For you?
Yeah, it did. I have a couple things in my notes. Well, one of the terpenes that it produced, and the other ones didn't. First of all, I'm going to qualify this by saying, since the terpene levels increased generally much higher, it may be that some of these more secondary terpenes didn't show up in the other tests. They were there, but they didn't get up to high enough levels to make it onto, to be able to quantify them. Okay. But osmine is antifungal. That was one of them that was what was there. The caryophyllene oxide, I think that's more of the curing process, because we saw that on both the control and the other one. That's in curing. The bisabolol, that's pretty interesting. That is an ergosterol inhibitor. So it inhibits, ergosterol are sort of like steroids, but they're going to deactivate the cell walls of the fungi, so they can't attach as well. So some of these that we saw may be part of the reason that they didn't have, or they had more of an antifungal reaction, and it could be part of the immune response of the plant to the fungi. What seems funny to me, though, is the ones that had the lowest amount of the Eagle 20 residuals had the least amount of fungal attack. So there's something else going on in the plant. The plant is making other secondary metabolites to fight off the fungi. And I don't think it's just the terpenes. I think, but those are volatile. You just said it. Those are volatilizing into the air. Are those, as they volatilize, are they having an effect on the genetics of the plant? I bet you they do. I haven't seen research on it yet, but I'd be willing to bet that there's more going on with volatile compounds than we know.
Have you ever seen
how of the genetics of the plant to make secondary metabolites?
Have you ever seen or read any experiments of what they've been doing with pinene and how it reflects light in the air?
Not exactly with pinene.
Because of all the pine trees and all the trees and all that stuff, pinene, it's one of the main predominant terpenes that get released in the air. I'll send you something. It was another person brought it up to me, and you triggered that thought too. It was like, what role do these play, these terpenes?
And also, you were saying about getting too high, the anxiety levels. That pinene is going to help remediate that, those effects, those euphoric effects. And it's not that it's going to make it so it's less potent. It's just going to cap it. There's some really good strains like of OG, Kush that are high in THC, but you only get so high and then just levels out for a plateau for a long time and it lets you down easy. Where others that don't have that same terpene profile, you shoot up like a rocket, get really high fast, but then you crash and you feel like crap. So I think that there's some of these terpenes that actually help remediate some of those intoxicating effects, help protect your memory so you don't have quite as much short-term memory loss while you're high, and to me, make it more enjoyable in general.
Why?
Some other ostamine is another good one. Terpinolene, both of those help remediate some of the other effects. I think in the future, that's where we're going to be putting a lot of our genetic research is in the terpene profiles, and some of the secondary minor cannabinoids. But I do believe, though, that they do have an effect on the plant because that's why the plant makes them. The plant isn't making them so we can enjoy our high. They're making them to help mainly to protect themselves. And some of those volatile compounds will trigger immune effects in other plants around them. And so the other plants around them that don't even have the disease pressure yet, or the insect pressure, they start to manufacture those secondary metabolites. And some are actually shared through the roots from plant to plant. So there's a lot going on there. And we know terpenes are part of the defense response of the plant. That's why they make them in general. But when they volatilize, that may be another part, a secondary effect of the terpenes, not just being directly antifungal.
Would that have anything to do with the mycelia, connection between the other plants? Yes.
Yeah, that does. That's another one that there's connections, and also just the roots themselves. There's a lot going on there that we don't understand, but I'm more interested in the volatile compounds. But even if that microorganism or fungus doesn't even touch the root, it still has an effect on the genetics of the plant. It activates different genes.
Yeah, that's very interesting.
You said like three things so quickly. So okay, real fast. Just to tie this in here through this whole conversation is, why do you think we saw a 50% the treatment soil that was treated with 5 mLs of drops of balance initially? Why do you think we saw a 50% increase in cannabinoid concentration?
It's a very good question. I don't really have the answer to that. Again, what I think is it has something to do with the activity of the microorganisms. That's what I think, because the ones that the soil that wasn't pre-treated actually had lower THC and lower terpenes than the control.
Say that one more time.
The plants that wort with pre-treated soil.
Oh, they have pre-treated. Yeah, they have the same amount as the control.
Yeah, but they had the same. They actually had less. The drops of balance
cannabinoids.
Slightly. I mean,
No,
The
3%.
Terpene was the same.
About
Slightly
2%.
less. Yeah.
And
So the pre-treatment is what had the effect on the terpenes and the cannabinoids, but I don't know what. I'll say this: the very first experiment that I already knew how it was going to come out, but I did it anyway, was I did a test for terpenes, color and aroma, secondary metabolites, especially getting into the flavonoids, the different pigments, and the terpene production. So what I did is I did the side-by-side trial, same environment, 3 different ECs, half strength fertilizer, full strength fertilizer, extra strength fertilizer. The ones with the highest fertilizer, highest EC, was creating some salt stress at the roots that had by far the most color, the most aroma, and highest flavors. I mean, you could see it in the jar. You could smell it without even doing an analysis. And so I just did. And I kind of knew that because if you're creating some salt stress, some stress on the roots, it's harder for the plant to take up water. And the plant needs to make more antioxidants to protect itself against stress. And some of those antioxidants are the anthocyanins, the pigments, and some of the other secondary metabolites. So what I did back, I applied what I learned in that experiment because that was right about the time when the dispensaries were playing the game. It used to be pretty high prices, and then they say, "Oh, okay, you bring your sample in. Where does yours fit in? This is top shelf. This is so much per gram. This is medium, and this is low shelf. Where does yours fit in?" You kind of go, it's somewhere up here. All right. So they kept lowering and lowering and lowering the prices on us. So I said, well, wait a minute. I'm not going to play that game with THC. I'm going to go with color and aroma. I'm going to go with terpenes and color, the deepest purple. So I picked a purple strain, had the genetics, and I did some different kinds of treatments. I did add the extra blue because that also stimulates the precursor molecules to the anthocyanins. But mainly I increased my EC. I changed my color spectrum at the end and had the darkest color, the richest aromas, strongest flavors. I brought that into the dispensary. So do you have any purple strains? Oh, yeah, we have a few. Well, let's compare them. So they brought down theirs. They brought down mine. There was no comparison. Now, mine was darkest colors. They opened it up. Wow, super strong, grapey smell. This is really good. I got the top price every time. Now, was that the best weed? The answer is no. The ones that had the more medium stress had more complex terpenes. The ones with the higher stress, they made more of those primary terpenes, but it was kind of overpowering. It was almost too strong. And it wasn't as good. It wasn't as enjoyable as the other. But I got the highest price. So, yeah, you can bring that out just with stress, especially with drought stress or with salt stress.
How about mold stress?
Time with drought stress. And when the plant recovers, it's going to make more terpenes. It's going to make more THC.
How about mold stress? I mean, because the controlled group, 2/3 of the crop went to mold. So it does mean that that whole crop was under stress the whole time.
Yeah, but the plant overcame it. The plants that overcame the mold stress produced the most secondary metabolites.
Yep. Higher than the controlled group.
Away.
Absolutely.
Yeah, I do think. I honestly believe that chitin is one of those things that trigger the immune response because that's what that. Okay, remember, I don't want to spend too much time here. We're going over, but we talked about those biostimulants improving the uptake of calcium, right? And that strengthens the cell walls. So when the powdery mildew lands on the leaf, it doesn't germinate on the surface water. It makes a tube. It gets to the water, interstitial space, and then it sporulates and spreads. Well, you get more calcium uptake. The cell walls were thicker. There wasn't water in the interstitial space. There was calcium pectate instead. So it couldn't get established and spread. But calcium is also a secondary messenger. The calcium that doesn't build up in the cell walls, the plant will pump it into the vacuole, the storage container inside the cell. So when a mold spore lands on the leaf, the plant literally, or a mold starts to germinate, the plant senses the chitin in the cell wall of the fungi. Plants don't have chitin. They have cellulose. So the plant knows it's under attack. It senses that molecule, chitin. So what happens, the plant sends a signal molecule from the surface of the cell to the vacuole inside the cell to open up calcium ions inside the cell. Thousands or millions of calcium ions flow into the cytoplasm, and they start to activate a series of enzymes that start what's called an oxidative burst. And that's the plant's first line of defense against fungi, that oxidative burst. And after that initial burst, it triggers a series of genes for the plant to start making secondary metabolites that fight off fungi, that fight off insects, and they have a wide range of protecting effects on the plants.
I think we covered the whole report. Was there anything else in your notes that you wanted to mention?
So there was lower on mold on both the pre-treated and treated groups. Yeah, here's something I didn't bring up, especially with the mold incidents. Some of those trace elements activate an enzyme in the plant that protects the plant against stress. So if it's under attack, it's under stress, okay, from the fungi. And that enzyme is called superoxide dismutase. And superoxide dismutase breaks some of the free radicals in the cell. It breaks down the superoxide into hydrogen peroxide and water, okay? And then other enzymes convert the hydrogen peroxide very quickly. But that enzyme, superoxide dismutase, has to be activated, has to be turned on by a cofactor, either an iron manganese cofactor or a copper zinc cofactor. Now, if it's activated, one molecule of superoxide dismutase can do 1,000 chemical reactions per second inside the cell. But if it's not turned on with an iron, copper, manganese, or zinc, then it's doing 0 chemical reactions per second. So I'm thinking there may be that the trace elements may have been activating the superoxide dismutase that the plant itself makes.
The one that drops the balance.
Yeah. The other thing is the chitinase that breaks down chitin in the cell wall. That the research kind of shows two different things. It shows that copper, iron, and zinc can inhibit the function of the chitinase that breaks down the chitin in the fungus. But others say that copper and zinc sometimes stimulate the production of the chitinase, the activation. So that could be just a balance there. Doing it too much, it's going to have one effect. Not enough, it has the opposite effect. With trace elements, as you all know, because you know your product, there's a very narrow window between deficiency and toxicity on the plant. And I also was wondering if the copper itself that's in the drops of balance may have an fungicidal effect, because we know the effect it has on microorganisms.
Yeah, and they use copper for vine crops for antifungal properties right now.
Yeah, they used a lot of it in Europe too, but then the Environmental Protection Agency in the UK and in Europe started to eschew the copper fungicides because the heavy metal, it was causing environmental problems. So they went to, as an alternative, they used a saponin that was in yucca extracts. The saponin, and the saponins literally are made by plants to deactivate the cell walls of the fungi. But they found when they just used the yucca extracts in water, it had just as much of an antifungal effect as the copper fungicides and chloranil and those other fungicides did on apples against the apple scab.
So they're natural plant esters?
Yeah, so they were able to deactivate the cell wall and activate the cell wall of the fungi so it couldn't get established and spread. It remediated it.
Is the case.
You take a 5-gallon bucket and you dump this water treated with the minerals at the base of the trunk, and you do it when it's gone into dormancy. You know, you can do it during the any time of the year, but the best time to do it is dormancy. And then the following year, you're supposed to see more shoots, more flowers. And so what I saw was on a 40-year-old apple tree. I moved into my house in like 2017. My wife was like, "We just need to cut these down." And I'm like, no, let's try to bring them back with this method. And so this year, it produced more apples than it ever produced. And all large size, like 98% of the apples were spot free. And they went all the way into November up here in Gaylord, and we had 2 freezes. This was this year. And even up, none of the apples fell from the tree. They were all healthily just continuing to ripen. So we had like a 3-month picking season. When we gave the neighbors some across the street, they ran over. They're like, we've never seen so many apples on this tree. Well, they've lived here for about 20 plus years. And when we gave them to them, they were like, these are the best apple pies we've ever made. These make the best apple pies ever. And so now we're probably going to be giving them that. But I wanted to share that with you because I'm doing actually kind of like a fruit forest type thing with trees and my own experimentation with it, and going to grow. I've already cleared the land, already plotted the trees, already planted them. But I want to share like some of my experience outside of, we're talking cannabis right now in this test is, the potential outside of that industry and looking at it is a biostimulant, by the way. I noticed you were talking about biostimulants. That's what they classified this as in Japan as a biostimulant. It's inorganic salts from mica, from biotype mica.
Mm-hmm.
Yeah.
And I bet you it's having a very significant interaction with some of the organic biostimulants in the root zone, activating the enzymes that those microbes are producing.
You still have the bottle I sent you? Do you still have the bottle I sent you?
I know. I was looking for it. I have your envelope. I have the jar.
Is it okay if I send you another bottle? Oh, it's right there. It's right behind you.
Yeah.
It's right behind you. That white bottle with the leaf and the water bottle.
Guess what?
Okay, perfect.
I do have it. I have it literally right behind me in my office on the shelf.
Well, if you want to,
look forward, I didn't see it. And it's right there.
You can add to your water and try it out for some drinking water for yourself.
Yeah. Hey man, I'm interested in what you're doing with fruit trees because I know one big problem they have with cherry trees. Huge problem is that they spray with an ethylene, and that will do is that loosens up the cells. So when they shake them with a mechanical harvester, more of them fall off. But chitin is also in the cell membranes of the outside of the cherry. So if you get hot weather, and that ethylene is going to produce more of the chitinase or the cellulase that breaks down the cellulose. So they get they lose a lot of cherries because they get too soft in August. You lose millions and millions of dollars. So what's going on too, probably if you get more of a biostimulant effect, the plant's taking up more calcium, is protecting the cellulose. It's making more cellulose and pectin, which means you're going to have better quality fruit, better shelf life, but more resistance to frost. Because I went through one of my first experiments. I went through 3 hard frosts on a experimental crop I was doing, and I didn't need to lose one plant when I had that increased calcium uptake. So I'm guessing there's a relationship somewhere between the drops of balance, between the other organic biostimulants that are being produced in the root zone, and some of those microbes are making different amino acids like glutamic acid and glycine that literally stimulate root cells to open up calcium ion channels. So it's not one thing. It's a combination of things that nature is doing and implementing together at the same time to have these positive effects. So I'm interested. I'd love to come up to Gaylord sometime and see what you're doing.
I'll exchange your guys' contact information. Would you also be willing to keep the drops balance in the back of your mind if there's ever any other research or experiments that are currently happening that maybe we could get involved with to bring more efficacy to the minerals and to kind of help explain what's the interaction of what's actually happening?
Yep. I'm not in the loop as much as I used to be, but because I'm retired. But I get calls from time to time from different people. I mean, light manufacturers and you name it. They want some advice in setting up trials.
Mr. Harley Smith, I appreciate you today so much on analyzing this report for us and helping us interpret it, really, because we only know so much. You know, you're an educated man around these things, and it allows us to just dive in deeper, know where to spend more attention as we approach new experiments. And thank you. We're very grateful for you coming on.
I'd say bottom line, last thought, if you can deactivate or protect the microorganisms and the root cells from heavy metals excess, that there's going to be a lot of beneficial side effects, many that we haven't even talked about today.
Thank you so much. I'm gonna go ahead and stop recording. I know some of the guys want to just say thank you as well. I'll hit right here.